Derive Poisson's equation in electrostatics from Gauss law. From differential form of Gauss law, we know the divergence of electric field is equal to 1 by epsilon 0 times the electric charge density, that is divergence of E, that is the electric field, is equal to rho divided by epsilon 0. Rho is the electric charge density and epsilon naught is the permittivity of free space. And we know when a del operator operates on a vector or vector field, that is called your divergence. So this is del dot E means divergence of E, and this is the differential form of Gauss law. So from differential form of Gauss law, we know divergence of E equal to 1 by epsilon 0 rho. Suppose this is equation 1. Again we know from the relation between electric field and electric potential, well known equation, that is electric field is equal to negative gradient of potential. We know when a del operator operates on a scalar, that is called the gradient, and when a del operator operates on a vector, that is called divergence. So here your potential function is a scalar function, so this is called gradient of phi or gradient of the potential function. So electric field is equal to negative gradient of potential, that is E equal to minus del phi. Suppose this is equation number 2. Now you substitute equation or from equation 1 and 2, you may write that del of, this is the divergence. So divergence of the gradient of phi. Here you see negative sign is here. So minus of gradient of phi. Phi is your electric potential. So divergence of gradient of phi, that will be equal to 1 by epsilon 0 times rho. So if you rearrange the terms, this is del dot del. So del square, this is your Laplacian, and you take negative sign to this side. So Laplacian phi, which Laplacian means gradient of divergence of gradient of a scalar field, or scalar is called your Laplacian. It is represented by the symbol del square. So Laplacian phi, either you write del square or you write capital delta. Both these symbols valid for Laplacian. So Laplacian phi will be equal to minus 1 by epsilon 0 times the rho. And this is your Poisson's equation in electrostatics. So in this way you can prove Poisson's equation in electrostatics from Gauss law. In the next video we will discuss what is the significance of Poisson's equation in electrostatics. Thank you.